Hello, welcome all my dear student of TYBSc physics class. In previous lecture, we have studied the bisection method, algorithm of bisection method, flowchart for bisection method, and one example related to bisection method. Now in this lecture, we are going to see the C program for bisection method. In order to prepare this C program, we have to include standard input output header file on current path, as well as we have to include math.h, that means math header file on the current program. Also we have to include conio.h header file, conio header file on current path. Also we have to include standard library file, which is also header file on current path, and then we have to define function x into x into x into x minus 5 minus x plus 5, okay, or say minus 10, okay, which is nothing but defined for function f of x. Now we are going to begin with void main. From this void main tells the compiler that program begins from here. Then in the body of main program, we have to define the variables which are real number, that is we can give x0, x1, these are the variable through which we can provide two values to the computer. Also we have to define the error, optimum 3 decimal point, and variable x2. Then we have to use the function clr for clear the screen. Then we have to provide the value, first value, to the computer through keyboard. For that purpose, we can use the input output function, enter the value, and this value may be of x0, okay, x0 is equal to, okay. Now when we enter this value or when we enter any value to the computer, that value should be read by that computer. For that purpose, scanf function is used, scanf, and here the variable is float type, and hence here we are going to use %f and ampersand x0, okay. Similarly, we have to provide another value to the computer. By same way, we can enter the value of x1, and same value should be read by the computer through this statement ampersand x1. So in order to provide the value and computer should read that value, we use these two printf and scanf function. After then, we have to check the condition. If the condition is f of x0 into f or its derivative, or we can say that another value, second value, f of x1, whether the product of the function is greater than 0. If yes, true, then the body of function f is printf. Here we have to guess, for that purpose printf the guess value incorrect. Okay, incorrect. And if value is incorrect, then function should have to exit. Okay, in this way if body is completed. Otherwise, if this is not, then we have to check the midpoint, and midpoint of two initial value is nothing but x0 plus x1 upon 2. This is the midpoint. Then do this. After then check the condition. If x0 and if f of x0 into f of x1 is whether greater than 0, yes, then again we have to prepare the body and x0 should be replaced by x1. If condition is true, then control come here. If this condition is true, then control come inside the body of if function and replace x0 by x1. If it is the condition is not true, then else control never enter the body. This control comes here and execute this body, and in this body x0 is replaced by x1. X1 is replaced by x2. Okay. Then again check the next condition, or for second iteration again x0 plus x1 divided by 2, and while here for that purpose do while function is used. While fabs again if while fabs function x2 is greater than or equal to e, then we have to print the value by the function, or we have to print the roots by this function, and that should be on new line. So new line operator use, and this comment the root of given values or given equation, and that is of given equation, that means x2, and this is nothing but floating type if we provide floating value. So and the value is stored at to the variable value result is assigned to the variable x2. So we have to print the value of x2 by using this function, and then get ch, and body of the main function is closed. When this program is executed, one message get displayed on the screen. After the execution of this program, first computer asks us, first enter the value of x0. Suppose we enter 1, then when we enter the value 1 or provide 1 and enter the key, then second message is displayed on the computer like this: enter the value of x1. Suppose we provide 2, then third message, that is computer execute the program and gives us the root of given equation, and the root of given equation that is x2 is equal to, and it gives the values 1.5. 855591. This is the result of this. That means this is the midpoint, or this is the root of two initial values 1 and 2. Okay, because we know that value of root square of 2 is 4 and square of 1 is 1. So when we give two values, then program is executed and this is the root of these two values. Okay. Now we are going to see second method. We know that bisection method is interpolation method, and now we are going to see another type of iterative method, that is open-ended method or extrapolation method. And example of extrapolation method is there are many more examples, or there are many more methods belongs to open-ended, or we can say that extrapolation method. Okay. Now one of the example or one of the method line or carried out by this open-ended is nothing but NewtonRaphson method. NewtonRaphson method. Okay. I am again going to tell you that this method, that is NewtonRaphson method, is open-ended or extrapolation iterative method. This method is also known as Newton method. NewtonRaphson method is also known as Newton method, and this method is a way to quickly find a good approximation for root of real valued function f of x is equal to 0. What I say? NewtonRaphson method is a way to quickly find a good approximation for the root of real valued function f of x is equal to 0. Okay. NewtonRaphson method is also used, or such type of method is used, uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. Okay. That means suppose this is a function and this is y graph represent the function, and on x graph we give the value of x, and this is the continuous function and this is the differentiable function. And again we draw the tangent and we find the exact root of the given equation. This is, suppose here the initial guess value. Here we are going to find out first initial value. Then after first iteration we will get the first root. Then after second iteration we get the second root. After third iteration we get a root. After fourth iteration we are again going to a root. But up to certain level we will get the exact root of the given function. Okay. So again, like a bisection method, here we are going to see the method for or methodology for NewtonRaphson method. Now, in order to understand NewtonRaphson method, let x0 be an approximate root. X0 be an approximate root of function f of x0 is equal to 0. Okay. Let the actual value is x1 is equal to x0 plus h. This is the actual value of the root. Actual value of the root x1 be given like this. Suppose this is equation 1. Since x1 is correct value or correct root, we can write f of x at x is equal to x1 and find out f of x1. Okay. And if we substitute value 0, then we will obviously get 0. Therefore, f of x1 is equal to what? F of x1 is equal to f of x0 plus h. This is the function. And this is also, if this is 0, then this is also 0. Okay. Now here remember that this function f of x 0 plus h can be extended or can be expanded by using Taylor series. This function here can be expanded using Taylor series, and Taylor series is a very simple series. That is, f of Taylor series is nothing but like this: f of x1 is equal to f of x0 plus f dash of x0 into h. This is the first order, or here we can write like this: h f prime, that is first order derivative of x0, then again h square by 2 factorial f double prime of x0 dot dot dot. This is the Taylor series. Okay, or we can say that this function with interval h can be extended by using Taylor series like this. Okay, here see here, value of h is very small. Here in this expansion, Taylor expansion series, value of h is very small. So we can neglect all the terms above the second term. That means first term, second term. After second term, we can neglect all the terms, or in other words, we can say that second and higher order derivatives are neglected because value of h is very small. And suppose this is equation 2. After neglecting the second and higher order derivatives, this equation gives us f of x1 is equal to f of x0 plus h f prime x0, and this is equal to 0. This is equal to 0 means what? This f of x1 is equal to 0. If we, and from this we can say that, or we can write f of x0 plus h f prime x0 is equal to 0. Meaning of this is nothing but this 0. Or when we rearrange this equation, obviously we get h is equal to minus f of x0 upon f prime x0. Okay. Now suppose this is equation 3rd. We can substitute the value of h from equation 3 in equation 1. After substituting the value of h from equation 3, we have new equation, and that new equation is nothing but x1 is equal to x0 plus, minus f of, x0 upon f prime of x0. This is Newton-Raphson formula. Okay. This is Newton-Raphson formula. Now, this gives the next approximation, and the next approximation, that is x1, and which is obtained from x0. Okay. So next operation, next approximation is look like this: x1 minus f of x1 upon f prime x1. This is the next approximation. Then after, suppose this is first approximation or iteration, this is second iteration, third iteration like this: x3 is equal to x2 minus f of x2 upon f prime of x2. In this way, in general, we can write xn plus 1 is equal to xn minus f of xn upon f prime of xn. This is the general formula, or this is called general, in general, this is the called NewtonRaphson formula. This formula is very useful, or without this formula we can't obtain or we can't derive the roots of given equation by using NewtonRaphson method. Okay. So, this Newton's formula is very, very important. This is called Newton formula or NewtonRaphson formula. Okay. Newton's Raphson formula. Now, there are certain limitations in this Newton's Raphson formula. Few important things to be followed when we use Newton-Raphson method in order to obtain the desired root of given equation. Which are the rule or which are the limitations? Here we are going to see some limitations of Newton-Raphson's method. What are the limitations? Or what care should be taken when what care should we follow, or what important things should we follow when we use Newton-Raphson method? First limitations or first care should be taken by the user is that for this method f of x0, that is first order derivative of a given value, should not be equal to 0. This is not equal to 0, first care. Otherwise method fails. If first order derivative of a given function is 0, then method fails to obtain the root of that given equation. Okay. If f prime of x0, that is first order derivative of a given function is 0, then change the initial approximation value quickly. Okay. Now, second limitation is that if initial guess is too far away from the required root, then process may be converged to other root. And third limitation, for better converge of the method, select x0 such that f of x0 into f double prime, that means second order derivative of 0, should be positive. What I say, for better converge of the method, select x0 such that this product of function f of x0 into second order derivative of the function given function x0 should be positive. Then and then the obtained root of given equation is correct. Okay. Now, we are going to see the example of Newton-Raphson method. But due to lack of time, we shall stop here, and next example for this Newton-Raphson method will be studied in next lecture. Till then, we shall stop here. Have a good day.